Having the 3D assembly and the appending P&ID drawing open, you see the connection firsthand. Select any component in the to-do list. It will be highlighted in 3D as well as in the P&ID diagram simultaneously in real time. Now we are going to add additional components and pipelines to the P&ID. We need a pump, which we are going to find in the component database by querying for it and placing it in the desired position. An automatic inquiry pops up and needs a unique tag number to fully define the component in the diagram. All other arrays get automatically assigned with the information and properties from the database. Symbols are getting connected with a line. First, the pipeline gets a unique number, and afterwards we assign a pipe spec and an appending pipe size. Pipelines and connected components which have a flow direction can be turned around by one simple mouse click. We are going to place a stop valve at the heat exchanger. Here, we also used a connection between the 3D pipe spec and the P&ID component database. The assigned pipe spec filters out only the admissible components from the database. In this example, the unique tag number gets created by a function which is automatically generating names. Placing the symbol, it rotates automatically to the line direction. The size of the connected pipes gets automatically written to the symbol. With an additional pipeline, we connect the pump with the tank. The procedure is the same as with the first pipeline. The intelligent design checks can be performed on the finished diagrams and only on specific parameters. Warnings and errors are going to be shown in a separate window and can be easily resolved from there. In this example, the size of the nozzle doesn't fit to the pipe size. The solution in this case is to change the pipe size. The new value is going to be displayed at the tank nozzle, which doesn't cause an error message anymore. With the Object Lister tool, it is possible to list the whole content of a diagram or a partially selected area and display it in a table which can be edited. You can generate different lists and reports like BOMs and parts lists from the drawing. A bill of materials, or a BOM, sums up all identical components by its article number. A component list analyzes components by its tag numbers. Apart from the usual export options, we also have an intelligent PDF export. Along with the visible geometry, you can also see the component properties in the PDF. Once the work in the P&ID is finished, you switch back to your 3D environment. After refreshing the to-do list, the changes from the diagram will be shown. The to-do list is helping the user implement changes according to the P&ID diagram. In this case, the pump gets placed first from the 3D library. And then we assign the component properties of P&ID to the 3D model. With the information from the P&ID, the 3D pipes are ready to be created. The function FromToPoints helps the user find the correct connection points. After a subassembly is automatically created, we draw a 3D pipeline path with the solid edge express route function, path express. To draw customized lines, just choose the line segment function. From the to-do list, assign all relevant information from the PNID to your 3D pipeline sketch. With a single click, the pipeline gets generated. In doing so, piping uses knowledge from the assigned pipe spec and takes only admissible fittings from the 3D library and places them on the path. The necessary valve is interactively placed via the to-do list. For placing the valve to the pipe, the native solid edge and mate functions are used. Hereinafter, recalculating the pipeline causes an automatic placement of flanges and gaskets at the valve. The last open task is to add a reducer to the pipeline. The required split point is being defined in the express route function. All following steps are queried and automatically processed by the software. After finishing this operation, all symbols appear green in the to-do list. For the user, this means that all information from PNID is now implemented in 3D. If required, the pipeline can be extended with pure 3D piping functions. In this example, pipe supports are needed along the pipeline. The dedicated function gives you the desired result fast and easy. With native solid edge functions, you can make precise adjustments to the positions of all supports correctly. Through standard CAD functions, all relevant pipeline parts get displayed. It is needed to create some isometric drawings of the 3D pipelines. During the generation of isometric drawings, all available information is taken out of the 3D pipelines and is used for generating the drawings. The final result, in this case a DXF file, can be viewed or edited in a proper application. Each isometric drawing contains information which is relevant for manufacturing this pipe according to the used template.